What's up, guys? It's Andy, and today we're going to talk about the quotient rule. Now, what is the quotient rule? Well, it's your worst enemy. I hate this rule, along with the product rule, but I definitely hate this rule more because it's tough to remember sometimes, and sometimes I just don't feel like doing it. So why do we have it? Well, recall that last lesson, I guess, last video, I showed you that you can take care of, like, you got something over here and something underneath it. You can just take the derivative of x, y to the negative 1. But sometimes that isn't the most efficient way to take care of things, so we created the quotient rule. And it's kind of like the product rule. This is the product rule right here. You got derivative of the first times the second plus first times derivative of the second. And we can work towards a quotient rule if we just write it like this: f of x times g of x to the negative first power. And we're just going to simplify this. We're going to make f of x u and g of x v. So now we got d dx u times v to the negative first. And what we find is when we differentiate this using product rule, we get this right here. So basically, well, you got u times, well, derivative of v to the negative first. Well, that would just be v negative second times a negative, and then we need to figure out through chain rule what v prime is, so we multiply that all by v prime, and now we add, well, derivative of u, that's just u prime times v to the negative first. And we can simplify this, and we get negative u v prime over v squared plus u, hang on a minute, u prime over v, and if we multiply this by v over v, then we get this right here: u prime v minus u v prime over v squared. Or alternatively, I'll write it like this: u prime v minus v prime u, just, so that way the prime's in the same spot, all over v squared. And that's actually the quotient rule right there. So it's u prime v minus u v prime over v squared. So that little algebraic manipulation thing is how we got there. And to show you why I don't really like this, I'm going to do some examples and torture myself a little bit, I guess. So we got x plus 3 to the third over x squared. Well, remember, it's u prime v minus v prime u over v squared. All right, so now we need derivative of this thing. Well, that's just 3x. 3 times 1, we don't need that 1. And now we multiply it times v times x squared minus, okay, so now we take the derivative at the bottom, which is just 2x, and then x plus 3 to the third over x to the fourth. And I think you see right off the bat why I hate this. If your teacher makes you simplify this, it's going to take a long time to do that. But on this channel, I don't really feel like doing that, so I'm just going to leave it as is. Now we got sine of x over 3x to the fourth. Well, I'm just going to write that down again. Alright, so we know that the quotient is going to be 3x to the fourth squared. And now we just take derivative at the top, so that's just cosine x times v, 3x to the fourth, minus, all right, derivative of that thing, that's just 12x to the third, sine x. And that's it right there. And the last example I'm going to do today is this one right here. Well, all right, let's take care of the bottom one first. So that's just x to the 14th, because that's x to the 7th. Square that, you get x to the 14th. And now, let's see, derivative at the top, that's 15x to the 4th minus 12x squared times x to the 7th. Now we got a minus 3x to the 5th minus 4x to the 3rd, and now x to the 7th, 7x6. And this reason, you see how it like expands up here and it's just messy? Well, that's why I don't like it, and it takes a long time to simplify. And trust me, like after you do this a few times, it will get easier, but you will never get over simplifying it, because simplification is generally not going to be one of your favorite things. But anyway, let's end this on a positive note. We're nearly through differential calculus. This is how you differentiate most functions. If you know the product rule, the quotient rule, the chain rule, and the power rule, then you basically need to learn specific examples, and we'll talk about that next time. So, this is Andy. Peace out.